right, modeling with linear inequalities. So this is the day 2 practice. I'm just going to run through a couple of the problems to give you a little confidence with getting started here. The tour director is hiring boats to transport a group of tourists across the river. He must make sure there is room for at least 28 passengers. That sounds like a total to me. The number of tourists in the group. A dinghy can seat 6 passengers, and a flatboat can seat 2 passengers. So we're writing an inequality, and we've already told you what x and what y are going to be. We need to take at least 28 passengers. So we can take more than 28 or equal to 28, so that symbol is important. Our total number of people we need to transport is 28. A dinghy can take 6 people, and our number of people there is, the number of dinghies is x. A flatboat can take 2 people, and the number of flatboats is y. So it's really helpful to have that grid. Once you get to the OST, the grid won't have that for you, but we will give it to you on the practice test and the test. Now, in order to graph this inequality, we need to solve for y. So I'm going to recopy that 6x plus 2y is greater than or equal to 28. Double check that there. And now we're going to solve for y so that we can graph. So in order to get y all by itself, we're going to subtract that 6x over and we're going to divide by 2. Divided by 2 is 14. 6 divided by 2 is 3. And I don't love that order there, so I'm going to flip it around. Y is greater than or equal to negative 3x plus 14. All right, now this is asking us to do a couple additional things. We need to label each axis. So over here we said x was our number of dinghies and y was our number of flatboats. And now we're going to graph. So on this graph, we are going to start at 14 on our y-axis. And our slope is going to be down 3, right 1. And before I go any further, I'm just going to check the scale here. Each one of my x and my y-axis are both going up by 1. So I'm in good shape here. I'm going to go down 3, right 1. It's okay that our x-intercept isn't beautiful. I'm going to make that line as nicely as I can. And it is a solid line here because we have an equal to. And then we're shading here, y is greater than, so we're shading above. Now, if we were in algebra 2, we'd probably have more going on with this problem because it doesn't really make sense to, if we only have to transport 28 people, it doesn't make sense to be able to transport that many more. But at this point now, we can name some combinations that would fit the scenario. So any numbers in our shaded area, we could take 5 dinghies and 4 flatboats. We could take 3 dinghies, and I'm going to go up here, and 7 flatboats. combination in that shaded area will absolutely work. You could just pick some ridiculous numbers. But it's nice, I think, to be close into that line. That would make sense for that company. Maybe have a couple extra seats just in case, so that families can ride on the same boat together, or in case you have some last minute additions to your tour. All right, that's your first linear inequality. I hope that was helpful and got you started. Try number 2.